So in this video, we'll be discussing topics from Chem 18 na kakailanganin natin sa mga concepts sa Chem 40. So for example, we need the concepts of periodic trends. We need the properties, okay, involved kapag ka nagkakaroon ng interaction between atoms. Okay. Next, we have bonding and bonding theory. So how do atoms form a bond specifically? Depende yun sa kanilang electronegativity values and the number of valence electrons they have. So we also consider geometry and polarity of those molecules when they form, kasi yung magiging interaction nila or yung IMFA nila, okay, this is IMFA, it will be dependent on the geometry and their periodic properties. Okay, so kapag nag-form ng bond, for example yung H and Cl, what type of bond will be formed? So we know that from Chem 18 to be a polar bond. Okay, so the polarity of the HCl affects its interaction with water, for example. So yun yung mga concepts na kailangan natin i-review bago tayo mag-proceed sa Chem 40. So the concept of effective nuclear charge is important kapag nagde-determine tayo ng periodic trends. So yung Z effective, for example, it's the measure of the actual charge or positive charge experienced by the valence electron. So yun yung positive charge or yung attractive force or attractive electrostatic force na na-experience ng valence electron from the center of the atom. Okay? Z is just the actual charge of the nucleus. Okay? So the actual nuclear charge depends on the number of protons. Okay? Kasi ang nucleus natin is made up of protons and neutrons, and we know that neutrons do not have charge. So yung protons yung mag-determine ng number or intensity ng positive charge dun sa center. This particular thing here is the shielding constant. So the shielding constant describes how the electrons on each orbital shield each other. So kapag mas malaki yung shielding constant, ibig sabihin yung valence electron mo, hindi niya masyadong na-experience yung charge from the center of the atom. So naapektuhan nun yung reactivity ng valence electron. And we know from chemistry that the valence electrons are very much involved in chemical reactions. Okay? So yun yung concept of the effective nuclear charge. So ano naman ang mga different fashions of shielding or different intensities involved kapag nag-shield yung mga electrons? So ang una natin ay yung shielding by N. So this is by N, yung number 1. So ano ang N? N is the principal quantum number. So as you go from lower N to higher N, you're basically increasing the distance of the electron from the atom. So for example, this one, this is N equals 1, so N equals 2. So great yung distance difference or yung distance ng N equals 1 orbital is smaller than that of N equals 2 with respect to the center of the atom. So ibig sabihin, if you have an outer electron sa N equals 2 and you have an inner electron sa N equals 1, yung electron cloud na na-form nung N equals 1, nagkakos yun para hindi masyadong ma-experience ni N equals 2 na electron yung full nuclear charge. Okay? So, imagine, mas marami tayong electron sa N equals 1. So, kapag mas maraming electron sa N equals 1, lalong nababawasan yung tinatawag nating Z effective. Okay? So, syempre, since these electrons are N equals 1, ito, ang experience nila is the actual Z. Okay? However, may effect pa rin naman yung mga katabi niyang electron. So, medyo Z effective pa rin to. Okay? Although the interaction between those electrons are not very strong compared to the shielding caused by the inner N. Okay? So, kapag nasa N equals 2 ka, na-feel mo yung shielding caused by the lower N. And if you are electrons on the same end, okay, nagkakaroon ka pa rin ng shielding effect, although it's at a lower degree or a lower strength. Okay? Doon naman sa mga iba't ibang L. So, ano ba ang mga L? That's azimuthal quantum number. So, L can be 0 1, 2, and 3. So, sa Gen Chem, meron silang letter notation. This is S, P, D, and F. So, yun yung mga L. Okay? Ngayon, ano yung mga shielding between the same N na electron, if you have the same N, but you have different L? For example, you have N equals 3. So, ang N equals 3, meron siyang 3S, 3P, and 3D. Okay? So, alam natin na yung 3S, it has a lower N plus L. So, di ba meron tayong N plus L rule. Okay? So, kapag mas mababa yung N plus L mo, mas mababa yung energy mo. Okay? So, this has an N plus L of 3. This has an N plus L of 4. This is an N plus L of 5. So, ibig sabihin, pinakamalayo sa nucleus si 3D, sumunod si 3P, sumunod si 3S. So, si 3S yung pinakamalapit sa nucleus. Okay? So, ano ngayon ang effect ng shielding ni 3S kay 3P at kay 3D? So, compare din natin yung kanilang dispersion or yung shape ng orbital. Alam natin na yung S orbitals, they are solid spheres. Okay, yung mga S orbitals. So, kapag solid spheres ang mga S orbitals, or they have spheres, pero sometimes kapag ka-higher N, meron silang mga nodes inside. Although the sphere is still very dense. Okay? Compare natin siya sa p orbital, which is a set of lobes. Okay? Yung p orbital, for example, this is the 2p orbital. Okay? Mas dispersed yung fashion ng p orbital kaysa sa s orbital. Yung d orbital, mas marami siyang lobes. Okay? So, mas dispersed yung d orbital kaysa sa p orbital, kaysa sa s orbital. So, ibig sabihin, kapag nag-shield yung S, okay, dun sa P, mas effective mag-shield si S kasi mas solid yung electron cloud niya. Yung P orbital, hindi niya masyadong nasi-shield si D from the nucleus kasi mas dispersed si P. Okay? And finally, D is poorly shielding kasi mas dispersed siya. So, kapag dating natin sa F, yung F orbitals are poorly shielding. They are actually the poorest shielders, okay, pagdating sa ganitong trend. Okay, so, yun yung number 2 and number 3. So, sa number 4, na-discuss ko na to, same electrons or electrons of the same N and L shield each other but at a very low degree or strength. Okay? So, number 5, the D and F orbitals experience more shielding than the inner electrons and sp orbitals. So, pansin nyo, kasi mas dispersed sila, so mahina silang mang-shield, tapos madali pa silang ma-shield. Okay, yun yung property nila. Kasi nga, dispersed silang electron, they are very sensitive to shielding. Pero hindi sila effective shielders. Okay, tulad ng mga mas dense na shapes ng wave functions, like spherical. Okay, so yun yung sa effective nuclear charge. So, anong effect ng effective nuclear charge sa size ng atom? So, if you go from left to right ng periodic table, so from boron, carbon, nitrogen, oxygen, fluorine, neon, ang nag-i-increase dyan, of course, is Z. Okay? However, hindi nag-i-increase yung N. So, ang N nito ay N equals 2. Okay? Boron is 2, S2, 2P1. This is 2S2, 2P2, 2P3, 2P4, 2P5, and 2P6. So, hindi nag-i-increase yung N at hindi rin nag-i-increase yung L. So, ang L nito ay 1 because this is a P region. Okay? So, ano nangyayari dun sa shielding constant? So, yung shielding constant nila ay medyo mahina or medyo mababa yung value. Yung nagiging increase ng shielding constant nila ay hindi kasing laki ng increase ng Z. So, ibig sabihin, as you go here, okay, palaki ng palaki yung Z, pero hindi palaki ng palaki yung shielding constant. So, nag-i-increase yung Z effective. So, pag nag-i-increase yung Z effective, okay, mas nahihila ngayon ng atom mo yung mga electrons niya. So, anong nangyayari? Nag-shrink yung overall size ng iyong electron. Okay? So, that's the reason why from left to right across the periodic table, okay, across a period, okay, so nagkakaroon ka ng decrease in the atomic size. Okay? So that's the trend. So ano naman ang nangyayari down the group? So pag down the group, nag-i-increase yung n. So pansin nyo dito, n equals 1, equals 2, 3, 4, 5, 6, and 7. So great ang difference nila sa n. Kasi isang ano to, period, isa. So this is down the group. So kapag nag-i-increase yung n, nagkakaroon ng mas effective na shielding. So malaki yung nagiging difference ng shielding constants nila. So that will compensate to the increase in the Z, okay? So nangyayari, yung overall trend ng Z effective, okay, bumababa. Kasi palayo ng palayo yung electron. Bukod sa parami ng parami yung electrons being shielded or shielding those valence electron, palayo rin siya ng palayo. So palaki ng palaki yung size ng iyong atom. So that's the trend down the group. So again, across the period, bumababa yung atomic size. Down the group, nag-i-increase ang size ng atom. Okay? Because of the Z effective. Another property is called the polarizability. So polarizability is the ability of your electron cloud to be distorted by an external charge or external electric field. Okay? So anong ano ang relationship between Z effective and polarizability? So kapag mataas ang Z effective, okay? Mababa ang polarizability. Bakit? Kasi isipin nyo, kapag mataas ang Z effective, mas malakas ang kapit ng central nucleus nyo or yung center ng atom dun sa mga electrons niya. So anong nangyayari? Okay? Hindi basta-basta na di-distort yung electron cloud. O the atom becomes relatively hard or this electron cloud is relatively hard. Okay? So kapag mas malayo naman, halimbawa yung electron mo dun sa center ng nucleus, okay, hindi nagkakaroon ng masyado o bumababa yung influence ng center ng nucleus or yung charge ng nucleus doon sa magiging behavior ng iyong valence electron. So kapag bumababa yung influence ng center dun sa valence electron, okay, bumababa yung Z effective. So kapag mababa yung Z effective, okay, mas mabilis ngayon nadi-distort yung iyong electron cloud kapag experience siya ng external electric field. So that's why, okay, tumataas yung polarizability. So polarization is what happens when the positive center of your atom and the negative electron cloud, okay, becomes separate entities or temporarily separates. Okay? So nagkakaroon ng polarization. So napupunta sa isang side yung negative charge, napupunta sa isang side or sa another side yung positive charge. So yun yung nangyayari kapag nagkakaroon ka ng polarization. However, this is temporary. Okay? Polarization is temporary. But the lifetime of the polarization depends on the Z effective of the atom. Okay? So, the trend, okay, of polarizability is the same as atomic size. Kasi pag mas malaki yung iyong atom, mas mabilis siyang napopolarize dahil mas malalayo yung valence electron niya dun sa center nung iyong atom. Kapag naman mas maliit yung atom, mas nagkakaroon ng control yung nucleus dun sa valence electron niya. So, mas nagkakaroon ng attraction, okay? So, mas nagkakaroon ng inertness towards external electric field. So, hindi siya masyadong napopolarize. Okay, so that's a polarizability trend. So, kapag left to right across a period, okay, nagkakaroon ng decrease ng polarizability. Okay, so decrease na lang. Lagyan natin decrease in the polarizability. Kapag down the group, okay, nag-i-increase naman yung polarizability. Okay, increase ng polarizability. Okay? So that's that can be explained using the same concept na ginamit natin dun sa atomic size. Okay? So that's a trend. So, across a period, nakikita nyo, bumababa yung polarizability, pero down the group, siya ay tumataas. Okay? So, next na concept natin is yung electronegativity. So, what is electronegativity per se? So, electronegativity is a property of the atom, okay, to hoard or to track electron density in a bond. For example, you have HCl. Okay? So, since Cl has a higher Z effective than H, okay, nagkakaroon siya tuloy ng parang dominance over the possession or dominance dun sa electron density. Kasi mas na-attract niya yung electron density kaysa sa hydrogen. Kaya polar ang HCl. Kasi mas mataas ang Z effective ng HCl kaysa sa H. So, nangyayari, halos lahat ng electrons napupunta kay Cl. At least yung charge density. Okay? So, that happens with various compounds. Nakadepende sa relative difference nila sa Z effective yung magiging resulting difference in the electronegativity. So, for example, then, okay, meron tayong carbon monoxide. Okay? So, yung carbon monoxide, mas mataas ang Z effective ng oxygen. Kasi from left to right, okay, across a period, nasa mas right yung oxygen compared sa carbon. So, anong nangyayari? Yung Z effective ng oxygen, lumalaki. Kasi mas marami siyang protons and hindi naman nag-increase yung N from carbon to oxygen. Actually, hindi rin nag-increase yung L. So, nangyayari dyan, mas electronegative yung oxygen kaysa sa carbon. Although the difference is not as intense as this HCl. Kasi mas malapit naman si carbon sa oxygen, but mas malayo si hydrogen kay Cl. Okay? So that's electronegativity. Electronegativity has an opposite trend is that of polarizability. Kasi left to right, okay, across a period, nag-i-increase ang electronegativity. Electronegativity is directly proportional to your Z effective. So pagka nag-increase yung Z effective mo, okay, nag-i-increase din ang electronegativity. So dito sa polarizability, we have already discussed that this is decreasing. Down a group, decreasing ang iyong electronegativity, of course, because the Z effective is decreasing. However, nag-i-increase ang polarizability. Okay? So ito yung graphical trend ng ating ionization energy and another concept called the electron affinity. So ang ionization energy, for example, you have a compound F, okay? Or sodium na lang. Sodium. Okay? That is the energy, okay? Yung energy na to needed, okay, to expel an electron, the valence electron of sodium. Okay? So, yung electron na to, para matanggal mo sa sodium, kailangan mo ng energy. And this energy is your ionization energy. Electron affinity naman, for example, meron kayong fluorine plus electron, okay? That is the energy released when fluoride forms. So, this energy is electron affinity. Ionization energy and electron affinity are both directly proportional. Okay? Proportional to Z effective. So, kapag nag-i-increase ang effective nuclear charge ng iyong atom, tumataas yung both ionization energy and electron affinity. Kaya, ang nangyayari, yung tendency, okay? So, pansin nyo, dun sa periodic table, okay? So, let's look at the periodic table. Okay? So, pansin nyo dito sa periodic table, yung mga elements na to, they have a high tendency of being cations for positive charge. Okay, while elements in here, okay, have a high tendency of being anions. Kasi if you go from here to here, kakaroon ka ng increase in the Z effective. Okay? So, increase in the Z effective increases your ionization energy and electron affinity, but it decreases your size and polarizability. That's why the smallest, okay, element here is fluorine or fluoride, and the biggest element is francium. Of course, this F orbital is just in the middle, okay? Kaya included pa rin sila sa trends. Okay? So, that's how you describe the trends as a summary. Okay? So, again, in summary, pareho ng trend ang ionization, energy, and electron affinity. Left to right across a period, nagkakaroon ka ng increase in the Z effective. Okay? And while down the group, you have a decrease in the Z effective. Okay? Yeah. So, let's take a look into electronegativity on a deeper level. So, yung electronegativity kasi, it describes the type of bonding, okay, experienced by your molecule or by the bond. Okay? Electronegativity is a comparative description of a bond. So, if your electronegativity value is between 0 and 0.4 according to Pauling, okay, Linus Pauling, you are considered a non-polar covalent bond. So, anong example ng non-polar covalent bond? Yung CH bond. Ang CH bond, so we can calculate actually using the Pauling electronegativity values, 2.5 minus 2.1. So, that's 0.4. So, the Pauling electronegativity for the CH bond is 0.4. Meaning, the CH bond is borderline non-polar. Okay. So, ano naman ang example ng polar covalent bond? So, yung OH bond, tingnan natin, 3.5. Okay. Yung oxygen, minus 2.1. So, 3.5 minus 2.1, that is 1.4. Okay? So, ibig sabihin, the OH bond is a polar covalent bond. Okay? So, ano naman ang example ng ionic bond? So, ionic bonds, usually yung ionic compounds na nakikita natin is NaCl. So, Na ito, and then Cl. So, 3.0 minus 0.9, that's 2.1 for the NaCl molecule. Okay? So, this gives you an idea about how bonds exist. So, nangyayari pala dito, nagkakaroon ka muna ng covalent bond, but then, due to the difference in the electronegativity, imbis na ma-share mo yung bond, ay actually naibibigay mo na siya minsan because of the difference in the electronegativity. Okay? Kaya yung iba ay ionic, yung iba ay polar, they can still share but not at the same degree. Pero you can share totally equally number of electrons. So, okay? So, you can either share equally, you can share unequally, or you don't share at all. So, that's the concept of bonding, according to the valence bond theory at least. Okay? So, yeah. Summary of values, 0.4, borderline non-polar, 1.4 for OH, polar covalent, and 2.1 for NaCl, which is ionic. So, sa next video, this will be a continuation of our review of Chem 18 topics.